Hello teachers and welcome to the presentation of Group 29. The presentation will be divided into three parts: problem overview, data cleaning and preprocessing, and model descriptions and comparisons. For problem overview, our research purpose is to explore how to predict whether a person's annual salary exceeds $50,000 based on his or her attributes. Since the dataset provides predefined class labels and a vector of predictor variables for classification. This is a binary classification problem. This dataset can be classified into two categories: numeric data and categorical data. For data cleaning, convert the question marks to none, change the column names. The percentage of missing values is 7.37%. Because each data represents one respondent, handling missing values by deleting entire rows. Some most likely outliers are identified above the 75th quartile for age and below 25th quartile for educational. Feature engineering and selection will be introduced below.
First, we have 14 features for our exploration. 5 are numerical variables and 9 are class variables. As we focus on the inference stage of our selected algorithms, the aggregate index variable is excluded. Using the forward selection, we have identified a list of top influential variables for the logistic regression on the top right, and a list for linear discriminative analysis on the bottom right. We use the logistic regression support vector machine, decision tree classifier, and linear discriminative analysis for our modeling. For comparison, support vector machine is more effective in high-dimensional space, while it's not suitable for large datasets. Logistic regression, on the other hand, can provide a comprehensible inference and has comparable accuracy with the support vector machine.
First, the essence of logistic regression is to use maximum likelihood estimation to estimate the parameters. Before fitting the model, we use forward stepwise selection to select the features with the best accuracy. The result shows the 5 chosen predictors. Also, it is important to evaluate the correlation matrix to ensure that the features are independent of each other. Now we use training dataset to build a logistic regression model to predict the results. The confusion matrix and calculated misclassification error show a good accuracy of 82.88%. Also, the ROC curve suggests the classifier performs good. Next, the support vector machine's algorithm is defining the feature space of the largest interval linear classifier. Before fitting the model, feature scaling is necessary for standardizing the features. Now we fit a linear and a nonlinear SVM to the training set to predict the class. The results show the accuracies respectively. Moreover, we use parameter training to try to improve our model. The genetic function uses grid search to adjust the hyperparameters of the statistical method within the parameters provided. So we use the parameter training results to fit a new nonlinear model, as the accuracy is 85.43%, is the best one. Now we move on to the decision tree classifier.
I'll be talking about the decision tree and LDA models. Decision tree is a machine learning algorithm that is widely used. It enables splitting the dataset into 2 branches according to specified conditions in which the leaf code corresponds to a class label and attributes are represented on the internal node of the tree. We did a random model at the beginning, but we found it very messy and we need to reduce the branches. Then we did k-fold cross-validation. We set k as 5 and the running time as 10. Lastly, we got 82.94% accuracy of the decision tree model. Another model is the LDA model. It firstly finds the directions to maximize separations between classes, then uses the found directions to predict individual classes. The Gaussian distribution is covered as well. In LDA model evaluation, we used the parallel function to speed up the running speed by providing the ability to allocate cores to RStudio and execute parallelly. The explanation of the output is shown on the slides. Finally, the accuracy of the LDA model is 82.08%. I'll hand it to Xiaohan and he will explain our model comparison.
Hi everyone, This is Xiaohan Ji. The evaluation shows that the SVM has the highest accuracy, and the AUC is also the highest. The AUC can take into account the balance of sample classification, indicating that the SVM model has the best performance in the test set. Among the other three classification algorithms, although the accuracy of decision tree is higher, the AUC is lower. Logistic model and LDA model showed similar performance. Based on our project, the SVM performs well in higher dimension, but it is slow and has poor performance with overlapped classes. Decision tree can select feature automatically, but it is prone to overfitting and is sensitive to data. The logistic regression is easier to implement, interpret, and very efficient to train. But if the number of observations is lesser than the number of features, it may lead to overfitting. The LDA requires the normal distribution and is not good for few category variables. Thank you for listening.